Alright, in this video we're going to look at multiplying complex numbers. And complex numbers can be multiplied much in the same manner that binomials are multiplied in Algebra 1, such as x plus 3 times x minus 8. We can distribute the x to the x minus 8 and then distribute the 3 to the x minus 8 and combine our like terms and we'll be done. However, since we have this, we're not going to be dealing with x's, we're going to be dealing with this I, which has a special meaning as the square root of negative 1. When we multiply x times x, we get x squared. When we multiply complex numbers, a lot of times we're going to end up with an I squared in our calculation. So if we square both sides of this equation, this I equals the square root of negative 1, we're going to get the relationship that I squared equals negative 1. So squaring the square root of negative 1 will give us negative 1. Squaring I will give us I squared. So that means that anytime we see an I squared in our multiplication, we're going to substitute a negative 1. So our final answers should not have an I squared in them. All right, example 3, we're going to multiply each. We're going to have 2 plus 3i times 5 plus 6i. Now, I like to multiply mine using boxes, or some people call this the lattice method, or whatever you call it, doesn't really matter. This just helps keep me organized to make sure I don't lose track of anything. So on the far left outside the box, I have the 2 plus 3i, and then on top, I have 5 plus 6i. It doesn't matter what order they go in. The 2 plus 3i could have been on top. Really doesn't matter. So to get what's inside each box, we're just going to multiply whatever's in that row by whatever's in that column. So 2 times 5 will give us 10. 2 times 6i will give us 12i. And now the next row, 3i times 5 will give us 15i. And then 3i times 6i is 18i squared. So really, this is just a way to help keep you organized with your multiplying this out. Now, we see the 18i squared here, and as we talked about earlier, I squared is negative 1. So this is actually 18 times negative 1, which we can rewrite as 18. So once again, we have 18i squared, but I squared simplifies to negative 1. So what's actually in this cell is 18 times negative 1, which we can erase what we had and just write negative 18. Now, if we look along the diagonals, we have like terms. Another advantage to using this. So 10 minus 18 is negative 8. 15i plus 12i is 27i. So our answer for example 3a is negative 8 plus 27i. For 3b, we have negative 1 plus I. We're going to multiply that by 4 minus 3i. So multiplying it out, negative 1 times 4 is negative 4. Negative 1 times negative 3i is positive 3i. And then distributing the 1i, or the I, 4 times I is 4i. Negative 3i times I is negative 3i squared. So once again, we have an I squared. That's actually negative 1. So this is negative 3 times negative 1, which is positive 3. So notice when we have a number in front of I squared, like negative 3i squared in this case, it actually just simplifies to the opposite of this number in front of the I squared. So we have negative 3 times negative 1 just becomes positive 3. And now negative 4 plus 3 is negative 1. 4i plus 3i gives us 7i. So our answer for 3b is negative 1 plus 7i. All right, 3c, 7 minus 7i times 7 plus 7i. We're going to see this in the next video. Multiplying it out, we get 7 times 7 is 49. 7 times 7i is 49i. Negative 7i times 7 is negative 49i. And then negative 7i times positive 7i is negative 49i squared. And remember, I squared is negative 1, so negative 49i squared is negative 49 times negative 1, or positive 49. Now combining our like terms, 49 and 49 is 98. The 49i and negative 49i, they cancel each other out to 0. So our answer for example 3 is 98. And notice we do not have any imaginary part to this answer. It's just 98. It's not like 98 plus 3i or anything like that. And we'll talk about that in the next video as well. So, but that's all for this one. Thanks for watching. I'll see you next time.